So let's look at an example of testing a hypothesis about a proportion using the p-value. So let's look at an example. The National Center for Education Statistics monitors many aspects of elementary and secondary education. In 1996, 34% of students had not been absent from school even once during the previous month. In 2000, a survey of 8,302 randomly chosen students showed that the figure had slipped to 30%. Do the figures give evidence of a change in student attendance? So our sample size, n, is 8,302. Our p-hat, which comes from our sample, is 30% or 0.30. Our p-naught is 0.34, and our q-naught is 0.66. So the first thing that we want to do is write the appropriate hypothesis statements. So our null hypothesis, or HO, that's the hypothesis that assumes that nothing has changed. So in that case, our p is going to be equal to 0.34. Our HA, or our alternative hypothesis, is p does not equal 0.34. Now I want to stop there just for a moment. Your alternative hypothesis could either be a greater than, less than, or not equal to. So the way that you would determine what your alternative hypothesis is you have to look at the question that's being answered. Or excuse me, the question that's being asked. So the question that's being asked is, do the figures give evidence of a change in student attendance? This is why I underline the word change. Because it's not asking me if it got less, it's not asking me if it got more, it's just asking me, is it different? Did something change? So in that case, we're going to use a not equal to, because all we want to know is it different than the 0.34? So that's why we choose to use the not equal to. So the next thing we want to do is identify what type of test is being performed, and what we're doing here is a one proportion z-test. Okay. Next, we want to look at our assumptions and conditions. So let's first look at our independence assumption. Okay, so for the randomization condition, the problem states that the students were randomly chosen. It tells us in there, a survey of 8,302 randomly chosen students. They're giving us that. Now the 10% condition, the 8,302 is less than 10% of all elementary and secondary education students. Okay, so with those two conditions being met, our independence assumption has also been met. So now we have to look at our sample size assumption. And our sample size assumption is going to go with our success failure condition. And we're going to look at n times p naught, which is 8,302 times the 0.34, and that gives us 2,823. N times Q naught is our 8,302 times 0.66, that gives us 5,479. Both of those are greater than or equal to 10. They're quite a bit greater than 10. So therefore, all assumptions and conditions are satisfied. Now we can move to our next step. The next step is to calculate the test statistic. Well, our test statistic z is equal to our p hat minus p naught divided by the standard deviation of our p hat. And the standard deviation of our p hat is p naught times q naught divided by n, and then you take the square root of that result. And so that'll give us the 0.34 times 0.66 divided by 8,302. We take the square root of that, and that gives us a standard deviation of p hat of 0.005. Now we take that information and we substitute all of our numbers in to calculate our z. So our p hat is 0.30, our p naught is 0.34, and our standard deviation of p hat is 0.005. So we solve for z, and that gives us a -8. Okay? So now what I'm telling you is, let's test the hypothesis at a significance level of alpha equal to 0.05. So what we want to do here is we want to find the p-value that is associated with a z equal to -8. Or to phrase it another way, we want to know the area under the curve that's associated with a z equal to -8. Okay. Now, -8 means that we are 8 standard deviations below the mean. Okay, so if you remember we were talking about our normal model, remember anything outside of 3 is considered to be unusual. Anything that is going to be 8 standard deviations below the mean is going to be extremely unusual. Okay? And then also, if we look at the notation on our z table, down at the bottom, you'll see where it says for z less than or equal to -3.90, the areas are 0 to 4 decimal places. So that is such an extreme value that there is no area under the curve. Okay? So in that case, the p-value for that is going to be 0. Okay, the area under the curve at -8 is 0. Now here's the key thing. This is a two-tailed test. Remember, we're doing it, it's a not equal to. Okay, that's a two-tailed test. So for a two-tailed test, we have to multiply our p-value by 2 to get the p-value for the hypothesis test. So obviously anything times 0 is 0. So for this hypothesis test, our p-value is 0. 0 is less than our alpha level of 0.05. So therefore, because we have such a low p-value, we are going to reject the null hypothesis. The p-value is less than the significance level. The final step that we have to do is to state our conclusion in the context of the problem. And so we would say, reject HO, there is evidence to conclude a change in student attendance at a significance level of 5%.